Hi, everyone, and thank you for joining us today for our Installation Intel webinar, Key Characteristics of HVAC Equipment Installation. My name is Kim Melton, and I will be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost is because of COVID restrictions, many of us are working at home. So if we run into any technical difficulties today, we will pause the webinar for 5 minutes, for up to 5 minutes anyway. And if we're not able to resolve those difficulties within that time frame, we will cancel today's webinar and either send you a recording or send you a rescheduled event notification. That way we'll be able to get you all the information without having any disruptive technological problems. So on that note, as we present today, if you have any questions, please feel free to submit them via the Q&A feature, and you should see that to the right side of your screen. If you don't see that there at the right top of your screen, you can click on the ellipsis in the bottom right-hand corner, and that's circled there on the right, and it'll open up a dialog box that says Q&A. And when you click on that dialog box, it will open the menu on the right side of your screen that will allow you to submit questions as you have them. Also, the information provided in today's webinar should not be used as a substitute for professional engineering design and/or documentation that's required by codes, contracts, or applicable laws. So please also make sure to refer to manufacturer-specific application guidelines and instructions and guarantee requirements on all projects. Also, we will be ending today's webinar with this today, and this is your opportunity to provide us feedback on how we've done today. You can use it to ask any additional questions you might have about the topic, or even suggest new topics for future webinars if you'd like to. But this survey is really part of how we deliver the JM experience to you, and the JM experience is based on 4 pillars of the JM culture, and those are listed there in the bottom left corner of the slide. Now, we believe it's critical to make sure that we hear and understand and respond to your needs in order to deliver the best interaction to you. And we offer webinars like this one to help educate the market and offer a tool and a resource for you and your business. But making sure that these webinars are valuable to you isn't just a one-way street. Your feedback is a key component to helping us evolve to better meet your needs. So if you have any questions or comments or suggestions as to how we can better accomplish this, or even if you feel like today that we haven't hit the mark, we'd encourage you to fill out the survey, and we'll use your feedback to improve our webinars and provide the information that has the most value to you in future webinars. Also, we're frequently asked whether or not we send out these presentations upon their conclusion, and while we don't send out the presentation itself, we do post a recording of it online, and that's to ensure that you can watch it at your leisure, share it with your colleague, and make sure that you have the presentation within its full context. So we will send an email directly to you when it's live on our website. With that, I'm going to hand it over to Erica Williams and Josh Boyce to introduce themselves. So Erica, if you want to go ahead and kick us off with introductions, that would be great.
Good afternoon. Thanks for joining us today. Despite the uncertainty that we're all waiting on in our world today, we want to let you know be assured that HVAC OEM equipment is status quo and good to go. My name's Erica Williams. I've been with the Johns Manville OEM group going on 19 years. All of that time in the OEM group, whether it has been as a market leader, which is more of a product position, or as the OEM channel leader, which is more of a sales position. Josh?
Good afternoon. My name is Josh Boyce, and I am a senior product engineer with Johns Manville, supporting the OEM team in an innovation and commercialization role. I've been with Johns Manville for just under a year now, but I've been out in the ceramic manufacturing industry for just under 12 years, working for various different industries. So let me start us off with discussing our agenda for today. I'm going to talk through some of the key characteristics for HVAC equipment installation, and then we'll do a little deeper dive into 2 of those characteristics, thermal control and acoustical control. And then Erica will finish us off by discussing some HVAC equipment installation selection criteria, and then getting into some of the installation solutions that we have within our HVAC equipment installation portfolio. So with that, let's talk through some of the primary functions of insulation. This really, when you think about insulation, the first thing that comes to mind is thermal performance or thermal control. But really, the functions of your insulation system are going to be dependent on the different type of application that you're talking about and the different type of system. Some things are going to require a high degree of fire protection or personnel protection. You may need to consider condensation control or freeze protection for subambient systems, or you may be just thinking about energy conservation, which can also help to reduce pollution within your total system. When it comes to HVAC equipment specifically, we want to help promote energy efficiency through thermal control. But another key critical component that we're going to talk about today is acoustical control, or how can you reduce sound or absorb more sound within your HVAC equipment insulation. And then something that we're not really going to do a deep dive into today, but can be a major component in different HVAC systems, depending on whether or not your insulation is exposed to an airstream, would be air erosion. And Erica will point out some of our products within our portfolio that are rated for different feet per minute when used within an airstream. So let's talk about thermal control. Thermal control or heat flow is really dictated by the laws of thermodynamics. If you think about having two different materials that you sit next to each other, one's hot and one's cold, they're going to want to move towards thermal equilibrium, where they're both at the same temperature eventually. And heat flow is going to be moving from areas of high temperature to low temperature, or from the hot material into the cold material. And how does it do that? There are three different heat flow mechanisms: convection, conduction, and radiation. And if we talk about conduction first, what is this? This is the transfer of heat energy through solid materials. So this is actually vibrations of atoms and molecules on the molecular level through a solid material. The material itself isn't moving, but molecules within it are moving. It does require physical contact. Examples of this, of conduction that you would see within your daily life, would be cooking in a pan, searing anything. And I know that the weather is getting colder, so a good example in our daily lives is holding a warm mug to heat your hands in the winter. The heat energy is traveling through the wall of that mug and into your hands. In HVAC equipment, we think that one of the main considerations here, especially if you're dealing with a burner system, would be making sure that you are controlling the conduction through the wall of your equipment so that you maintain a safe touch temperature on the outside surface of your equipment. Second mechanism would be convection. Convection is heat transfer through the movement of liquids or gases, and that can be air, water, etc. But the gases themselves are actually moving, or the molecules are moving. It's easiest to think of this through water. So in a system that's boiling, you have a heat source at the bottom. The molecules are heating up and expanding, becoming less dense. Those hot or less dense molecules will rise, and the colder molecules at the top will drop down and create this current. Examples, like I mentioned, boiling water, but also hot air balloons. If you think about how they're constructed, you have a heat source at the bottom. It's heating air. That hot air lifts and provides rise to the hot air balloon. And then as it cools down, the hot air comes back down towards the burner. The way that this would be applied within an HVAC system would be something like a steam radiator, how that's heating an entire room. Your air is being heated by the radiator lifting up, and then cold air is replacing that and getting heated, and so on and so forth. Also, cooling coils, the way that you use condenser coils to transfer heat. The last mechanism would be radiation. Radiation is the absorption or giving off of electromagnetic energy, or photons. Radiation is different from the other two in the fact that it does not require a medium to transfer heat through. So you can transfer heat via radiation in a vacuum. Great example of this is the sun. The sun is heating the earth. Heat energy is moving via radiation through the vacuum of space and heating the earth's surface. Or in our industry, if you've ever been near a glass furnace, especially if you have a viewing port that opens up, you feel that glowing hot on your skin. Radiation is always happening, but it does play a lesser role within a lot of the HVAC equipment. It requires a pretty large temperature differential to become the dominant heat transfer mechanism. So it does exist, but in most instances, we're going to be considering either conduction or convection for heat transfer. So how do we measure thermal performance? Thermal performance is generally measured via a steady state heat flow meter. We use ASTM C518, which dictates the method for that. In OEM insulation, we would typically test products to a 75-degree mean temperature. So in the diagram on the right, you see a piece of insulation. There's a cold plate up top, there's a hot plate underneath, and there's a heat flux meter that's measuring through. And what you do is you set a temperature differential, and you're looking for 75 degrees in the middle there. Just a point of reference, there are 3 different ways that people would talk about thermal performance. That would be thermal conductivity, which is standard for 1-inch thick product, thermal conductance, which varies based on product thickness, and then sometimes you'll hear R value, although that's more discussed in building type insulation. R value is just the thickness divided by thermal conductivity. As we talk about the thermal performance of all of our materials, we're going to be showing you values in thermal conductivity because it's the easiest. It's the easiest to compare. They're all 1-inch standard thickness. So thermal performance is something that's going to vary greatly by the different types of materials. As you can see on the left, steel has a thermal conductivity, or K value, of 300, and fiberglass all the way on the right has a thermal conductivity of 0.24. And I believe that these units are BTU inch per degree Fahrenheit hour square foot. I know it's a mouthful, or in other units it would be watts per meter Kelvin. But just to point out, the lower the thermal conductivity number, the better the insulator it will be. The higher the thermal conductivity number, the more conductive a product will be. So when you're thinking about thermal performance, you also need to not only think about what is the thermal conductivity, or the insulating value that you're looking for, but what is the temperature range that you need to work within. I'm showing a bunch of different insulation materials on this graph. Really, we're going to be talking about fiberglass today, which is kind of in the middle. We generally use fiberglass in a range from 0 up to 1100 degrees Fahrenheit. There are different reasons why you would select different insulation materials, be that your ultimate temperature range, how hot or how cold you need to work your system is going to be, or thermal performance. But there are also things such as weight, the form that it comes in, how easy it is to install within your system, and the cost of the material itself. So Erica will touch more on some of those selection criteria later, but just something that we want to keep in mind. So why fiberglass for thermal performance? On the left, you can see a micrograph of what fiberglass looks like through a microscope. It's a system of randomly oriented glass fibers, really long glass fibers. held together with some binder. But those randomly oriented fibers provide a non-direct path for conductive heat transfer from one side to the other. And then it also creates air pockets within the bulk of your insulation that make a very tortuous path for any kind of convective heat transfer. So with that, let's move on to some principles of acoustic control. Why is acoustic control why is it important? Things like background sounds can be disruptive, especially if it's intermittent. If you think about working in an office and someone stops by wherever you are and they're having a conversation, that can be disruptive to your concentration. Or as a lot of us are working from home, if a car pulls up with loud music outside, that can throw off your concentration as well. So really, we're trying to absorb as much sound from some of the ambient sources as possible. How this plays in an HVAC system, you can have multiple different sources of sound and paths. You can have sounds coming from your equipment itself. You can have airflow through your ducts. You can have sound moving from one room to the other via those duct systems. We're really going to focus on how can we minimize the amount of sound coming from your equipment. But that said, just a quick plug here. If you're interested in understanding more about how you can reduce sound transmission through HVAC ducting, we do have an upcoming webinar with our HVAC group and our on-site acoustician. So how is sound measured? What is sound? Sound is mechanical waves moving through a medium. So sound does require something to move through. It is not transmitted in a vacuum. But those waves can move through air, they can move through a liquid, they can move through a solid. We measure sound, those waves, two ways. One would be the frequency or how close together those waves are. That might also be referred to as pitch. We would measure frequency in hertz. And then you can also measure sound in volume, or how high are the peaks and valleys in your sound waves. That's measured in decibels. How does insulation help with acoustic control? Well, very much in the same ways that it helps in thermal performance. If you're thinking about how a wave could be transmitted through a piece of insulation, it can move through the solid or it can move through the air within fiberglass. So those randomly oriented fibers provide a tortuous path. They don't provide a direct connection from side to side, so you lose some of the conduction through or the conduction of sound waves, but it also provides air pockets, randomly oriented air pockets. So the sound waves moving through air also don't have a direct path through. Some ways that we can affect sound absorption through fiberglass would be through altering the fiber diameter, altering the density of the fiberglass itself, the fiber to air components, and also through the material thickness, your mounting method, whether or not it's faced. One thing of note here is that as we get into noise reduction coefficients, or how we actually measure it, this is like the K value, or the equivalent of K value for acoustic absorption. This noise reduction coefficient, or NRC, is a single number from 0 to 1. 0 being perfect reflection of sound, 1 being a theoretical perfect absorption of sound. This number varies with thickness of your insulation. So as Erica goes into some of the product offerings, if you see a range of values there, just know that that represents different densities and thicknesses. But how is an NRC value determined? We measure that via a reverberation room method, or ASTM C423, where you put a piece of insulation into the room and you hit that with different frequencies of sound, and you measure how much of that sound is absorbed versus reflected at different frequency bands. So a typical graph for an NRC is shown in the right side here. And you can see we're averaging over those different values, and that gives you, or over those different frequencies, and you end up with a single value of somewhere between 0 and 1. With noise reduction coefficient, or NRC, the higher the number, the better the acoustic absorption will be for you. So with that, Erica will get into some of the selection criteria.
Thanks, Josh. When we talk about OEM HVAC equipment products and solutions, we're really focusing on thermal and acoustical insulation for inside the HVAC box, such as furnaces, residential air conditioning units, light commercial air handlers, heavy commercial air handlers, heat pumps, mixing boxes, and the like. Johns Manville offers thermal and acoustical insulation for the air distribution and ductwork portion of the HVAC application, but our focus today is on the equipment or inside the box applications and products. System-dependent insulation criteria is really about how you need the HVAC equipment to perform and what physical design limitations you might be working with, such as operating temperature of the unit, noise levels you desire or don't desire, how big or small the unit needs to be, is the unit expected to have a service life of 5, 10, 25 years, etc. When we talk about material criteria, here we're considering potentially how the unit is manufactured or processed. As an example, how much time does the OEM have at the installation station, for example? Does the material need to be glue applied, pinned, maybe welded? Other considerations can be more basic, such as what density or thickness is required. Does the unit need to meet certain life cycle costs? Does the material comply with industry standards or requirements? If so, which ones? Continuing with design considerations, whether it is the unit itself or the material specification, some of the primary design details we typically discuss with our clients and customers during a design review are thermal performance, air velocity needs, acoustic needs, sustainability or environmental. As an example, does your design require Green Guard certified products, or do you have an eye towards IAQ, which is indoor air quality, or potential design impact for COVID-related applications? So let's take a look at product solutions, starting with face products for HVAC. Face products are really designed for applications in the airstream. Let's start off with products called ToughSkin and ToughSkin 2. These are unique products in the marketplace, really unicorns. They're a best-in-class product. No one else produces a dual-density composite with high-density skin and a low-density core with excellent acoustical control in both high and low frequency applications. The basic difference between the two products, ToughSkin and ToughSkin 2, is the density of the finished composite. ToughSkin is slightly higher density overall, composite density, than the ToughSkin 2. In each of the product charts that you'll see in the upcoming pages for each of the products, they're all going to list temperature limits, K values or thermal values at 75 degrees Fahrenheit, NRC or the acoustic values. These are details that Josh just covered. We'll list if it's GreenGuard certified and thickness options. So for tough skin, you can see the thermal values registering between 13 and 48, with acoustic values between 45 and 1. It is a GreenGuard certified product and available in thicknesses between 1/2 and 2 inch. Toughskin 2 is similar, although the thermal values go up to 0.52. They have the same NRC values. Toughskin 2 is also GreenGuard certified. This product is available from 1/2 to 1.5 inch, and both are designed for Airstream applications with a maximum velocity up to 3,600 feet per minute, or FPM. Micromat is our flexible blanket-type fiberglass insulation faced on one side with a smooth, durable, non-woven fiberglass mat. Micromat also has a temp limit up to about 250 degrees Fahrenheit, with thermal values between 23 and 26, NRC values between 45 and 80. It is a GreenGuard certified product, available in densities between 1 and 2 pound and thicknesses between 1/2 and 1 inch. Micromat, comparatively, can withstand Airstream velocities up to 5,000 FPM. Micromat RX is our flexible fiberglass equipment liner with a durable matte facing and an acrylic coating that contains an EPA-registered immobilized antimicrobial agent to protect the product from damage by mold and mildew. The temperature limit remains the same as the other products we've talked about. You can see the thermal and acoustic values. Of special note to Micromat RX, this is a GreenGuard certified gold product. This means that it's usable by children in schools, which is a rigorous emission standard threshold. Micromat RX is available in densities between 1.5 pound and 2 pound density and thicknesses from 1/2 to 1. Micromat RX can withstand air velocities up to 5,000. And again, that acrylic coating that's antimicrobial is wonderful for moisture resistance. Our last product in the face product line is our X-Acto-Mat. This is a flexible, resilient, blanket-type fiberglass insulation faced on one side with a smooth, durable, non-woven treated mat. It is manufactured with extremely close thickness tolerances. In that picture, it is the product that's standing on end with the yellow fiberglass and black facer. To note, this product, X-Acto-Mat, is GreenGuard certified. And again, notice that it is designed for narrow cavities within the HVAC equipment. So available in thicknesses from 1/4 inch up to 1 inch, and densities ranging from 3/4 pound to 3 pound. X-Acto-Mat can withstand air velocities up to 5,000 FPM. Moving on to our unfaced solutions for equipment, HVAC equipment applications. The first product is the matriarch of the portfolio. It's been around forever. It's a high-performance, general-purpose roll product. It has a wide range of density and thickness options. It's a lightweight and highly resilient blanket-type thermal and acoustical insulation made of flame-attenuated glass fibers bonded with a thermosetting resin. Flame-attenuated is a certain fiberglass process. This process pulls the fibers, makes them long. It flame attenuates it. It flame pulls the fibers so that they're long and thin. And when the fibers lay on the collection chain, weave, if you will, or how the fibers are distributed is a very tight weave, as compared to a rotary process product, which tends to have shorter, wider, or fatter fibers, which just provides a different feel to the product. It will have different performance metrics around it. So back to the microlite as a flame attenuated product. It has a temperature limit of 350 degrees Fahrenheit, so a bit higher. K values ranging from 22 up to 30, acoustic values from 25 to 90. It is also a Green Guard certified product. Density ranges from 6/10 pound up to 3 pound density, and thicknesses from 1/4 to 3 inch in thickness. Again, a high performing general purpose fiberglass roll product. Our next product is the SG series. Now this is a rotary process product, so compared to the microlite that I just spoke about, they're produced using 2 different processes. This is a wonderful product with a wide range, like the microlite, of density and thickness combinations available. It's really most applicable to double wall, but certainly can be used in other applications where you might need its K value or thickness options. You'll see that it goes up to 4 inches all the way down to a 1/2 inch product. Note that it is Green Guard certified. And to note on SG series and a few other products, this product has a high percentage of post-consumer recycled content at 56%. Our next product is called DuraCore. It's a lightweight, highly resilient product made with high core strength. And that's really why it was designed in the first place, to have excellent core strength. And core strength is meaning the interlaminar strength between the fibers, that it won't pull away from itself, where it's designed to stick to an equipment wall and not fall apart or flop over on itself, if you will. So DuraCore has the same temperature limit of 350 degrees, a thermal value of 24, NRC values between 40 and 65. It is Green Guard certified. Densities available in 1.8 or 2 pound, and in thicknesses from 1/2 inch to 1 inch. DuraCore also has the high post-consumer recycled content at 56%. Our next product is the Tough Glass Valuelite, and this is the last of the unfaced products in our portfolio. This is also a general purpose product with good core strength. It's a lightweight, highly resilient product made from borosilicate glass fibers manufactured using the rotary process. The K values between 24 and 25, the thermal values. The NRC between 40 and 65. It is Green Guard certified and available in densities of 1.3 or 1.6 pound density and thicknesses between 1/2 and 1 inch. Tough Glass Valuelite does have the high post-consumer recycle content of 56. Moving into our board solutions for HVAC equipment applications, we have 2 to talk about today. The first is X-Acto-Board. It's a rugged board type fiberglass insulation specifically designed for use in air conditioning units and other air handling equipment applications. And this is an interesting product because it actually comes to you as a roll, and we call it a rugged board type product because it's coming to you as a roll, but when you unwind it and cut it, it sort of snaps to a shape, if you will, where a regular roll product would lay as it lands, so to speak. So the X-Acto board product is really great for applications that have minimum space requirements where you may need that rigidity. And it's great for airstream velocity up to from 1600 to 2000. It has thermal values between 22 and 23, an NRC value 20 to 30. It is Green Guard certified and available in thicknesses 1/4 inch and 3/8. So again, those thin cavities with a boardy type product in densities of 2 and 3 pound density available. The last board product to talk about is our equipment spin glass board. This is a rigid board manufactured from fine rotary processed glass fibers bonded with a thermosetting resin. There's a couple of different options with this product line. We can produce this plain, meaning no facing, inline, of course. We can also inline add an FSK, which stands for foil scrim craft, and that would be on the bottom side of the board. And we can offline add a black acrylic coating for a black surface. So in the temperature limit portion of the chart there, you see those different temperatures identified. So for an unfaced or plain board, you have a temp limit of 450 degrees. And the FSK and coated boards coming offline from us, temp limits of 150 degrees F. Thermal value is 23, NRC value of 70 up to 1.05. It is a Green Guard certified product. It has the high post-consumer recycle content of 56% as well. It's available in densities of 3, 4 1/4, and 6 pound, and thicknesses between 5/8 and 4 inches. So as we're wrapping up at least the product part of the portion of the presentation, we've walked through product options and solutions for your HVAC equipment design. To circle back and conclude, Johns Manville has a long-standing history of leading and supplying the OEM HVAC equipment market segment. It is a core business for us curated to address your system design performance requirements. In collaboration with our knowledgeable fabricator partners, Johns Manville has the HVAC equipment solution for you. The bullet points listed here are really the touch points that we've talked about, things that you might want to consider as you're looking through the product portfolio, what product might be available to you or might work for you. Please don't hesitate to reach out to us with any questions. We do have additional resources that Kim will talk about, so I will hand it over to Kim.
Great. Thank you so much, Erica. So as Erica said, we do have a variety of additional resources that are available to you if you're looking for technical specification information. And these are resources that are really in place to help you make sure that you are selecting the right materials for your application. So the first one I'd like to talk about is our OEM engineering portal. This is an online portal from the OEM portion of our website. And basically, it goes through our product specifications. It has sustainability information. It has a list of tools that are available to you. And then it also has these webinars like today's webinar that are recorded that you can watch or share with your colleagues. So the OEM engineering portal is, unsurprisingly, for engineers. But it does have a lot of really relevant information for anybody who's looking for those highly specific specification information for their products and for the materials that are going in their products. A second tool we have is the JM Smart Binder. And what the Smart Binder is, it's an online app. Well, it's an app. All apps are online, but it's an app you can download to your smartphone, whether it's an Apple or an Android phone. And basically, it has all of our technical documentation for our products, from our SDSs to our data sheets, And this is really so that you can have fast, easy access to JM product documentation. So if you're looking for a data sheet, if you're looking for an SDS for a specific product and you perhaps don't have easy access to the website, the JM Smart Binder is a great tool to download to your phone for free to make sure that you do have access to that information and you have it quickly. And the next thing I'd like to talk about is our environmental product declaration. So I know Erica talked at length about a number of the products that we have for our HVAC equipment installation offering. But most of those products are Green Guard certified. And what the environmental product declarations are is they are a life cycle assessment of the impact that the impact that the product has throughout its life cycle from inception to taking it out of the system, and the impact that it has on the environment. So what we have is environmental product declarations for a number of our products, and you could get to these, like I said, if you go back to the engineering website, engineering portal, you can get to them from the sustainability tab. And the information that many people need to specify materials for Energy Star or even for LEED specifications, or even if they need the UL Green Guard certification, that is all available there on our environmental product declaration page. So for everybody who attended today, we will be sending you a certificate of completion. This will be in your inbox by next week. And this is going to come to you via email, so if you can use this to submit it for professional development hours. So if you have any questions about that, please feel free to reach out. So with that, I'm going to dive into some of the questions that we've gotten. Just a reminder, you should see a Q&A to the right side of your screen, and you can use that to submit questions. The first question we have, and Erica, I'm going to give this one to you, and Erica and Josh, if you both want to go off mute right now, that'd be great. The first question is, what fiber is the best in OEM equipment?
I assume that's, well, that I can look at that a couple of ways. So we're, of course, talking about fiberglass here. Hopefully the question wasn't about mineral wool versus fiberglass versus any other type of technology. So at least within the JM portfolio, there's the two types of fibers that I touched on, which is one option is the rotary process, the shorter, fatter fibers, versus the flame attenuated, also known as pot and marble process fibers, which are longer, thinner. I would really say it depends on the application. And of course, that would be the answer. There's so many variables to consider. If you have a thin cavity, then of course the pot and marble products are going to be available in thicknesses that are going to fit better. They have great thermal values. But the rotary process products work wonderfully as well and have different attributes. So I think you're really looking at what cavity size are you dealing with, what air velocities do you need? Do you need it to stand up on its own? Are you going to pin it? You know, all of the variables that we touched on. I don't know that I can say which one is the best. I know that we certainly have fiberglass products that will perform to the required criteria that you're looking for.
All right, thank you. Josh, is there anything you'd like to add to that?
No, I think that Erica handled that one perfectly. You know, it's not just about which fiber is the best. It's a whole systems approach. And so it's really difficult to just choose one versus the other without understanding everything else that goes into the effect.
All right, thank you. So we are getting a number of questions coming through about HVAC systems, as in the ductwork. Those are questions that we will address privately offline because they don't apply to today's webinar. So for those of you who are submitting questions about the ductwork and you don't get them answered, don't worry, we'll reach out to you privately. However, we do have any questions pertaining to the HVAC equipment itself we will address today. So the next question we have, and Erica, you kind of already just touched on this. Actually, I'm just going to skip over that one. Josh, let's go with you for this next one, and that is between mineral wool and fiberglass. Which one is better for acoustical purposes?
Ooh, Yeah, that one again is going to vary a little bit based on a lot of factors. So in general, you need to take into account the density, the thickness of the product that you're looking at, and whether there's a facing or not. But if you're talking about the same density and the same thickness of product, the mineral wool fibers will tend to be a little bit shorter, so you might get some slightly better performance from an acoustics perspective there. But again, that's such a case-to-case basis.
All right, thank you. Erica, is there anything you'd like to add to that?
I would, just from an application standpoint, in my experience, JM offers both technologies. So I would say consider weight, actual weight of the unit. Mineral wool is going to weigh more. And I've seen that come up with different models. So just something to consider.
All right, thank you. So similar question. When we compare mineral wool and fiberglass for HVAC equipment installation for thermals, which one is better? Josh, we'll start with you.
In general, the fiberglass I believe is going to be a little bit better, but you're going to have to discuss, what different thickness are you looking at, or what different density.
All right, thank you. Erica, this next one is for you, and that is, can you talk a little bit about fiberglass insulation and mold issues?
Sure. Fiberglass is inherently not a food source for the buggies, for mold and mildew by itself. There's nothing that makes up a fiberglass product that can sustain mold and mildew. However, you have dirt particles that fall on the material or some food source, some organic food source that might be laying on the surface that could sustain mold and mildew, but fiberglass itself cannot sustain mold and mildew by itself.
All right, thank you. Josh, is there anything you'd like to add?
So the typical way that's tested is via ASTM C1338. So that is a regular test that we reach out to third-party laboratories to test for.
All right, thank you. So Josh, the next question is for you, and that is, what insulation thickness do we need to provide on a low temp air, 45 degrees and less Fahrenheit, to prevent condensation in unconditioned spaces?
Yeah, so that's a great question. I think going back to some of the tools that Kim proposed there, I think there are a lot of factors that you need to consider for that, and one of the tools that you could use on our website would be the JM3E Plus tool to help you calculate the specific insulation thickness that you would need for that kind of environment.
All right, and I would encourage you for the person who submitted that question, in the survey, if you'd like somebody to reach out to you to discuss this personally, we could absolutely do that. So just please indicate that in the survey if you'd like that. So Josh, the next question is for you, and that is, I've written a lot of insulation specifications as a consulting engineer, but I always struggle with what density I should specify. Can you provide some guidelines?
Wow. Yeah, that's great. It's a good question. Again, it's going to really come down to what's your system look like. So density to specify is going to be a little bit of a challenge, just to give you an overall, this is how you should do it. I would encourage you also to check out the JM3E Plus tool. That may be able to help you a little bit with density and thickness, but you really need to consider all kinds of things. What are the operating temperatures? What's the maximum thickness that you can have within your system? Do you have any other considerations? Erica mentioned certifications like Green Guard Gold. Do you need to meet any of those requirements? So some of those other considerations may help you narrow down on densities that would be available for you. I hope that answered the question pretty well.
I think that's a great start. Erica, is there anything you could add to that?
I would just say I always start with the basics, right? What thermal and thickness are you working with? From those building blocks, then you can taper down which product might work best for you. But I start with thermals and thickness first.
All right, thank you. So our final question for today is, could you provide a reference tool to calculate economic thickness for equipment for thermal insulation? And Josh, I know you've mentioned the NAMA3E Plus tool. So can you just talk a little bit about how that works?
Yeah, I believe that was developed in cooperation with NAMA, which the name of that organization, what that acronym stands for, is failing me at the moment. But it's a tool where you can put in all kinds of different criteria, material that you're putting the insulation on. You can adjust thicknesses, you can adjust the hot and cold surface temperatures, and so you can use that to calculate what different insulations may work within your system.
All right. So that sums up our questions. We don't have any others. If there were any questions we didn't get to, that's because they were related specifically to ductwork. So we will have an HVAC person who handles the ductwork side of it reach out to you. If you have any questions that you weren't able to submit today, I encourage you to submit them in the survey that's going to pop up on your screen as soon as we close out the webinar here. And then everybody else, thank you so much for your time. Josh and Erica, thank you for the presentation today. And we hope you guys have a great week.